Good morning, students. In the complex compounds, our next topic is crystal field theory. Previously, I explained valency bond theory. You know that already drawbacks of the valency bond theory. What are the drawbacks are present here? Valency bond theory doesn't explain the stability of complexes, exact stability, and color properties of the complexes and magnetic properties of the complexes. Here the stability means thermodynamic stability as well as kinetic stability of the complex compounds. Magnetic properties of the complexes doesn't explain it by valency bond theory. These drawbacks is overcome in the crystal field theory. These drawbacks. What is the crystal field theory? Here, according to valency bond theory, complex is formed. Complex compounds are two types: octahedral complexes as well as tetrahedral complexes. In the octahedral complexes, around the central metal atom, how many ligands are surrounded? 6 ligands are surrounded. The 6 ligands are existing in octahedral complexes. Here, the ligand, ligand. As per the valency bond theory, this structure is like a symmetrical arrangement. Symmetrical arrangement means the bond length between metal and ligand, all the 6 ligands have equal bond length. Then the structure is called a symmetrical structure. But as per the crystal field theory, the complex compound is not a symmetrical. Few complex compounds. Why it is happens? How it is explained? Simply as per the crystal field theory, all the bond lengths between metal and ligand is not equal. That is explained in John Teller distortion based. So now look at the crystal field theory, what is telling. Before going to the crystal field theory, you know that already in the valence shell of metal, d orbitals are present. D subshell is present. The d subshell having how many d orbitals? Once look at the, before going to the crystal field theory, d orbitals exist. Before going to the crystal field theory, once look at the metal d orbitals arrangement of the electrons based on the axis, the 5 d orbitals, before going to the crystal field theory. Know that metal having the 5 d orbitals in the valence shell, d subshell having 5 individual d orbitals. The 5 d subshells are dxy, dyz, dzx, dx square y square and dz square. The 5 d orbitals, dxy, dyz, dzx, dx square y square, dz square. In the dxy, what is the xy indication? What is the yz indication? Xy indication means the electron density is revolving based on the x-axis and y-axis. Electron density is revolving based on the y-axis, z-axis. Electron density is revolving based on the z-axis and the x-axis based. That is the meaning of that. So these 5 d orbitals are existing as a 2 sets. The 2 sets names are, one is T2Z, another one is EZ. T2Z indicates electron density present between the axes. Electron density present between the axes. EG indicates electron density present along the axis. Electron density is present along the axis. Which d orbitals existing along the axis? Which d orbitals are existing between the axis? The d orbitals dxy, dyz, dzx. These 3 are called as T2G orbitals. The electron density existing between the axes. The remaining 2 orbitals, dx square y square and dz square. These 2 sets are simply called as EZ, electron density present along the axis. How they are revolving between the axis, along the axis? Once look at the orbital diagram also, these orbitals diagrams. Now first orbital, what is the first orbital? dxy. dxy, for example, here this is x-axis, this is y-axis, x-axis, y-axis. What I said, dxy, dyz, dzx, electron density is revolving between the axis. Here the between the x-axis, y-axis, x-axis, y-axis. You know that already d orbital shape is double dumbbell. This is one dumbbell, this is another dumbbell, that is the double dumbbell shape. So electron is revolving between the axis. Between the axis. Another orbital is dxy, after that dyz. Here this is considered as y-axis, this is considered as z-axis. So electron density is revolving between the axis. Here the between y and z axis between them. Another orbital is zx. So this is considered as x-axis, this is considered as z-axis. So electron density is revolving to axis based. These three orbitals are revolving. In these three orbitals, electrons are revolving between the axis. Between the axis. Remaining orbitals, dx square, y square. This is x-axis, this is y-axis. So electron density is revolving along the axis. So along the axis. The meaning here the electron density is present along the axis. This is called as the lobe is here. This area is called as, what is that? Node. Node means electron density is 0. This area is node. This area is node. Here in this area, maximum electron density. The probability of finding of electron density is maximum. That is, we know that. dz square. The dz square, electron density is only present on z-axis based. We are representing like this. The meaning of this indicates remaining two axes, electron density is 0. Only electron density is present on z-axis based. So, based on the revolving of electron in the complex compound, approaching of ligands towards the metal atom, based on that, yeah, crystal field theory explanation is existing. Crystal field theory explanation. So metal having the d orbitals, the 5 d orbitals divided into two sets, T2Z and EZ. So if the ligand approaching is, if it is comes to the along the axis, or if it is comes to the between the axis, based on that, the splitting of the 5 d orbitals are existing. Why the splitting of the 5 d orbitals is happening? Because of metal d orbital having the electrons, ligand also having the electrons, between them repulsions are existing. Due to that repulsions, the 5 d orbitals are split into two energy levels. Splitting two energy levels. The two energy levels is simply T2Z, EZ. T2Z, EZ, two energy levels, but the splitting is depends on approaching of the ligand towards the metal atom. How it is approaching of the ligand along the axis or between the axis? If along the axis it is approaching towards the metal, splitting is how it is existing. If between the axis it is approaching, splitting is how to existing. Crystal field splitting, crystal field theory. In the crystal field theory is based on the repulsive interactions between metal d orbital electrons and ligand electrons. That is the main point. That's why orbitals are splitting. Before splitting, the 5 d orbitals are degenerate. Degenerate means all the 5 d orbitals energy is same before approaching of the ligand. If the ligand is approaching towards the metal, the 5 d orbitals are split into two energy levels. Then complex formation is taking place. That is the main theory is existing in the crystal field theory. Now look at here, crystal field theory in octahedral complexes as well as tetrahedral complexes.